All right, let's start some game theory analysis. These problems were 17, 18, and 19 in the version A quiz that I accidentally wiped out as I made the version B quiz. But I have it in hard copy. Anyway, we have this game here, and player B plays left or right, player A plays up or down. This one has no meaning, but except as a practice. No team missed number 20. No, I need to switch to my pen. No team missed number 17, but here called 21. But what's player dominant strategy? I want to use it as a chance just to tell you how to think about these things. Well, the way we think these through is, let's suppose A thinks that B is going to go left. What's A's best play? Well, A could go down and get 5, go up and get 60. 60's better than 5, so if player A thinks player B is going to go left, player A is going to go up. And you do the same thing from A's perspective. What if A thought player B was going to go right? Notice we're thinking through player A's decision by asking, well, what is B going to do? This is the key. It's the strategic interaction among firms. Well, if player A thinks B is going to go right, A could go down and get 50 or go up and get 70. And again, player A's best play is to go up. And notice that we only have a 2x2 game here, so no matter what A thinks B is going to do, A's best play is up. And that's the definition of a dominant strategy. If regardless of what your opponent does, your best strategy to play is the same, then you have a dominant strategy. Notice the game, we have the players. Let me change colors. We have players. We have the strategies for player B. The possible strategies are to go left or to go right. Player A, possible strategies up and down. And then we have the payoffs for each combination of outcomes. Those are the 3 elements necessary for a game. All right, onward. Suppose both players make their choices simultaneously and independently. What is the Nash equilibrium of this game? Well, the Nash equilibrium of this game is, it's often called the no regrets equilibrium. And the dictionary breadth definition is, given the actions of the other players, no player has the incentive to change her action. So we know player A is going to play up because they have a dominant strategy. And let's think about, so we're going to have to be player A. We're going to have to see player A playing up if player A is going to be regret-free. Let's think about player B. Just for kicks, let's think whether player B has a dominant strategy. If player B, let's use yellow, if player B thinks player A is going to go up, player B wants to go left. If player B thinks player A is going to go down, player B wants to go left. So it turns out player B also has a dominant strategy. Well, the Nash equilibrium then is going to be where both players play their dominant strategy. We have one coming up where there isn't. Neither player has a dominant strategy. We'll talk about Nash equilibriums in that, Nash equilibria in that context. All right, so B is going left, A is going up. That makes it number B. That's our Nash equilibrium. So do practice these. It's a different way of thinking, but again, in negotiation and game theory, my grad school classmates studying game theory are all teaching at MBA programs, teaching negotiations. Just think through the problem from your rival's perspective and make your best play with that in mind. Is this game a prisoner's dilemma? Well, the prisoner's dilemma is a classic type of game, and to be a prisoner's dilemma, there has to have to be a few things going on. One is that both players have a dominant strategy in a prisoner's dilemma, and here we see that both players have a dominant strategy. The dilemma part of a prisoner's dilemma comes from the fact that the Nash equilibrium in the prisoner's dilemma game is worse than some other outcome that's available, and here that condition is not met. We have both players play their dominant strategies, but notice that set of plays brings them to the mutually best outcome. Some texts call this the invisible hand game, where that's the game that Adam Smith saw out his window, that people just pursuing their own narrow self-interest brought society to its best outcome, and thus competitive markets are the best. If we have them, they should be left to allocate resources. But anyway, that's what we have here. We don't have a prisoner's dilemma. Notice that every other outcome has got an aggregate payoff of less than the 120 that we get when player A plays up and player B plays left. 75, 75, 100. All of them less than 100. So no, it's not a prisoner's dilemma. Answer C. All right, that's it for these three. And nobody missed number 17, but I thought I'd talk about that anyway.